Okay, let me try and make sense of a question for you. So initially they said react hydrogen with oxygen to produce water. And then we had to balance it. So we've got those numbers there. And they also told us that we have 25 grams of this and 73.7 grams of oxygen. Okay, so first we want to figure out which one's the limiting reactant, because I have information about each reactant, so I need to figure out which one's limiting. So which one I don't have enough of in comparison to the other one. So like, and I can't compare grams, of course I got to convert to moles, but so this says for every 2 moles of hydrogen I need 1 mole of oxygen. So just throwing some numbers out. What if I had 30 of these and 20 of these? Okay, so I want to know which one's the limiting reagent or reactant. So this one says for every 2 hydrogens you need only 1 of oxygen. So if I have 30, it would mean that really I'd only need 15. Because what I do, from 2 to 1, I divided by 2, right? So if I take 30 and divide it by 2, I get 15. So really, if I have 30 moles of hydrogen, I need 15 moles of oxygen to react. But I have 20. If I have 20, then I have too much oxygen. So this one would be an excess, and that forces this one over here to be the limiting reagent. So always, limiting reagent is one of them, and excess has to be the other one. You can't have one that's the limiting and excess. Doesn't happen. So one's limiting, one's excess. Okay, so that was just a quick little example, but let's see what you've got set up here. So you converted the 25 grams into moles. So this is how many moles that you have. Okay, that's how many moles of hydrogen that you have. Okay, now when you multiply it by 1 over 2, which is correct, 1 over 2, this green number here tells me how many moles of oxygen I would need. Okay, so if I have this many moles of hydrogen, I need half that many moles of oxygen. Okay, so let's see how many moles of oxygen we have. So you took this number, divided by 32, it came out to this many moles of oxygen. So now compare these two. This one here is how many I have, and this one up here, the green one, is how many I would need if I was reacting all of that hydrogen. So when I compare them, this number here is way smaller than this one. So it means I don't have enough oxygen to react all of this hydrogen up there. Therefore, the oxygen is my limiting reagent. Okay, so that's correct. So if it's my limiting reagent, then I forget about basically I get rid of all the stuff that I've done so far, this part here, and I do stoichiometry, my solid to moles, and the question I think asks for solid, so I need to do these 3 steps. Convert solid to moles, moles across the river, and 3 moles back up to a solid. Okay, but step 1 we've already done. You've done that one right here. So you've converted the limiting reagent, the one you don't have enough of, you've converted that to moles, so that's step 1, done. Now step 2, what did you do here? Oh yeah, so step 2, that you're doing it right there. So this many moles of oxygen, and you multiply it by, now in this case here, what we're wanting is to figure out how many grams of water. So we don't want hydrogen, we're wanting to go over to water, because they're wanting to know the mass of water. So this should be 2 moles of water over 1 mole of oxygen, that's correct. So you double that, so this is how many moles of water I would get if I let that reaction proceed. Okay, so once I know that, so that's, I would be right here. And now I do have to do the third step, which would be to convert this one into grams. So the third step would be moles is equal to mass over molar mass. So mass is equal to moles times molar mass. So I have mass, the number of moles right there, 4.60 whatever, times the molar mass of water, 18.02 I think, grams per mole, times those together, and that would be your mass of water. And then round it to the right sig figs. Okay, now one of the questions that they ask, just while we're on this, let me change to red. I wonder if I can get a different color. Oh, green. Oh, yeah, we already have green. Let's go yellow. And make it up. I can't make it bigger. Oh well. Anyway, so one of the questions asks for excess. So what mass of the excess reactant is left over? So we determined the oxygen is my limiting reactant, so the hydrogen must be the excess. So I got to figure out how much I have left over. So to do that, what I need to do is figure out how much of that hydrogen actually reacts. So then I would do stoichiometry again between oxygen and hydrogen. So the number of moles of oxygen I have, that's the limiting reagent, is this one right there, is that right? Yeah, 2.303, etc. moles. And I want to know how many moles of hydrogen I would need this time. So I'm going to multiply that by what I want is 2 moles of hydrogen over 1 mole of oxygen. So when I multiply that, that's going to give me 4.6 something moles of hydrogen. So that's how many moles of hydrogen will react. But then let's look to see how many moles of hydrogen I actually have. Right up here, that tells me how many moles of hydrogen I actually have. So to figure out how much I have left over, I would just subtract them. So 12 point, I'm going to round that. I'll say 12.4, and down here I'm actually only reacting 4.6. So if I subtract those, that'd be 8, that'd be 7. So I'd have about 7.8 moles of hydrogen left over that didn't react because all the oxygen's used up because it was the limiting reactant. So then they want to know what mass of excess reactant is left over. So this is how many moles of hydrogen is left over. So then I'd need to use this formula again. Moles times molar mass. There's my moles. My molar mass of hydrogen is right there. I'd throw that in there, times those together, and that would tell me the mass of hydrogen left over. Okay, hopefully that helps you out with that question. Give me a holler back if you still have questions.